For this particular problem, I used the supervised regression using Excel, and the goal was to predict the net hourly electrical energy output, which was PE, and then the evaluation matrix I wanted to use were the R squared and mean square error. Considered all the features like temperature, ambient pressure, relative humidity, exhaust to vacuum, and I figured out that the temperature might have the maximum impact and the ambient pressure would be the next. The relative humidity and exhaust vacuum I thought would not have a lot of impact or variance on the thing. So for the data splitting, I used cross validation. I kind of took the entire data set and then split into 2000 and then ran the linear regression on each of them. And as you can see, the 80 has the higher impact, as you can see by the absolute value, which has a higher closely followed, by the vacuum, and then the AP and then RH have relatively not a significant impact. And you can see that the R squared value implies higher than 0.5, which is close to like 93, that it has a close reliance. And this was confirmed using the various data sets which we trained on. And the other models I considered was the gradient descent and the random forest. Again, for random forest and gradient descent, you cannot do it in Excel, so I did not try. We might be able to do it using the Python, using Panda libraries. But at least what I did after creating was I took the entire data set and figured out like, hey, how was the R square and the mean squared error, and on the final model evaluation test, they confirmed that a high value around 93-94% that the linear regression model can work on that. These are some of the screenshots I created, and the highlighted portion shows that the temperature and vacuum have a high correlation on this one. Thanks for looking at the data for me, and hopefully this provides this one. Again, maybe gradient descent or random forest might even have a higher value, but that's something I did not try for this assignment.